Aloha, Rich Halverson here. This is ICS211. And in this video, I'm going to continue on with Chapter 2. So let me share my screen. And here we are. Today's the 23rd, which... Okay, so yeah, I'm going to do like around this stuff. Okay, so let's go to what's all textbook. So let's go to the textbook. And oh, by the way, make sure you have done your weekly engagement this week. This is the first week. Got to do this so I know that you intend to take the class. Or you can let me know some other way. But if I don't hear from you, I'm going to, I have to mark you. It's a federal requirement. I got to mark you as not participating. And then if you decide that it was a mistake and you should have filled it out, there's a process. So. All right, so Chapter 2 is see, have we must have gone through Chapter 1. I don't know why nothing's checked off, but let's just do Chapter 2. Chapter 1 is, well, they're all easy. Okay, so if it says it's optional, that means you don't have to do it. Okay, it's there because you may want to reference it. You may have had this book last semester, and you know, you want to be able to reference it. So but don't do any. But so it doesn't do any good. Well, you should read it if you want to, but you're not going to get any points for checking it out. Okay, here's this first section in Chapter 2 that counts. So it talks about variable declarations, talks about the how memory is allocated. This allocates the memory, and then this is going to write. When you see the variable on the left side of an equal sign, then you know something's being written into it. To get the points, you got to make sure you click through these things, and so you got to click forward till you see allocate a variable space for it. Then you go down here and you print some stuff out there, and then you go down here and you read in something that the user types in, and then you're going to print it back out. All right, so make sure you go through, you understand all this. It's simple stuff. It's mostly helpful if you come from a different programming language, but if you come from Java, this should just be like why are you making me do this? All right, so let's do a challenge activity to make sure you understand how these challenge activities work. So the first one here is you're just supposed to, play computer. We're going to declare a class. We're going to declare two integers, one called x, one called y. Then we're going to set x equal to 9 and y equal to 5. And then we're going to print this out. We're going to print this out. Okay, so what does that look like printed out? Well, the value of x is 9. And then you're going to print a space. You're going to print 9. And then you're going to print a space, and then you're going to print the value of y. So it's going to look like this. And you're not going to print a new line. So that's that. Got all the points. The next one is I see this. Is it the same thing? X is 8. 2. Something funny about this. This is going to be x is 5 and y is 2, and that's all. Oh, x is reset to 8. All right, so that's what it looks like when you get an error. Well, just click next and it'll give you another chance. So look, it gives me another chance. X is 8. 8 space 1. Y is 1. Okay, very good. What's next? X is Y. Okay, Y is 6. And then X is same as Y. So they're both 6. So it's a 6 space 6, it seems. All right, what's the fifth one? You have y, and then you're going to add 3 to it and store that into x. So 6 plus 3 is 9. So x gets 9. So it's 9 space y is still 6. Okay, so you see these are very simple. I'll let you do this one yourself. This is a real hard one. Okay. Assigning a sum. Okay, so here we're gonna we have declared a variable called num coins and one called num nickels and one called num dimes. We assign num nickels and num dimes to values, and then it looks like we're going to print out num coins. So what we have to do is we have to write a statement that assigns num coins equal to this plus this. So I'm going to copy this here. And I'm going to put that right here. And then I'm going to put an equal sign there. Num nickels, num dimes, num coins, and I'm going to put a semicolon and see if this is the answer. Oh my, that's the answer. All right, this says you can also initialize variables at the same time you declare them. Same time you allocate the space for them, you can actually put something in there. One statement declares an integer variable called num hoses, which is initialized to, so I'm going to say, I'm going to copy this part, copy, and I'm going to say paste, and I'm going to say int num houses equals 25. I got to throw a semicolon in there someplace. I'll just put it. Okay, how's that? All right, well, that was easy. So make sure you go through this. Here you're allocating stuff and writing stuff out, doing some calculations. Oh, here's another one. Adding a number to a variable. Okay, so write a statement that increases num people by 5. If num is, okay, so increases num people by 5. Okay, so I'm going to copy this part. And we got num people, and we're going to put our solution here. Okay, so I'm going to paste my solution. And I'm going to put a semicolon there to separate, put a couple tabs there. And I'm supposed to increase it by 5. How about if I just do this? Plus equals. All right, let's see what's next. That's got an error because you got to have the variable on the left side and the value on the right side. That might be okay. I think this is okay. And then no, because num years does not have a value. It's just initialized. Is this an error? I think it's an error because unless there's something in between here which assigns num years a value, yes, being used without being assigned a value. It's got to be on the left side of an assignment statement. It's got to be on the left side of an equal sign before it can be on the right side of an equal sign. Okay, this last one here, assign an integer variable that with that. Paste. Start. I'm going to say start first. Okay, copy this. And I'm going to paste it here. I'm going to say equals 20. Semicolon. Put a couple tabs in there. All right, is this right? This is just all too easy. I'm just doing this so you understand how to do these challenge activities later on. I'm not gonna. Later on, I'll probably just do like the first two or something. Do a couple of them, you gotta do the rest of them. All right. So now okay. So you read in the number of cookies, and then you subtract 2 from it. So you go num cookies subtract 2. No, 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 no. You go cookies remaining. Cookies remaining equals num cookies minus 2. Okay. Well, this one, the bus drops off 3 people, and so we're supposed to write the statement that reduces num passengers by 3 people. So what we have to do is write num passengers equals num passengers minus 3, semicolon. And of course, the shortcut version of this is you would put minus equals 3. Same thing. And we're printing out the same variable. All right, what's the last one? Okay, we're supposed to figure out a total. The classroom has num chairs and num tables. The classroom's number of chairs increases by 2 times. By 2 times. The number of tables increases by 6 times. Write statements to update num chairs and num tables, then assign a variable total furniture with the total number of chairs and tables. Wow, that is a toughie. Okay, well, first we need to multiply num chairs by 2. This multiplied by 2. This gets multiplied by 6. And then they get added together. This plus this equals that. So first we're going to num chairs times 2. I can do it the shortcut way. I can do num tables. I can do it the shortcut way. And then I got to add the 2 into and store that value into total furniture. Furniture equals num chairs plus num tables. All right, is that right? Why? Yes, it is. All right, that's 2.2. Okay, so we did. Let's see. We did 2.2. 2.3 is optional. Optional. Oh, here's floating point numbers. Floating point numbers is not optional. And then science. Oh, all these are not optional. Wow, this is a pretty big chapter. Maybe I won't get all the way today. Is there a time? It didn't say how long. But anyway, all right. So let's go to let's go to this floating point. A floating point number is a real number containing a decimal point that can appear anywhere or float in the number. Okay, blah, blah, blah. So you declare it by using the word double instead of int, to use double. It's a good idea to put, 0. If you're going to say 0.0, it's a good idea to put, if you're going to put like 0.5, it's a good idea to put a 0 in front of it. But I don't think you'd have to. We'll have to test that out here. So anyway, and instead of doing next int, instead of when you're using the scanner to read in the input, it's looking for a, you can put in a number that's got a decimal. All right, so make sure you declare a double variable named person height, double person height. See, isn't that right? Yeah, okay. So anyway, we'll go through this and make sure you understand how to do all this. Make sure you understand, best practices. And then let's see if there's a couple of challenges down here. Okay, first one. Given sphere radius, the radius of a sphere, compute the volume of the sphere and assign sphere volume equal to the results. Use 4/3 4/3 to perform floating point division instead of that, because that performs integer division. And this is the formula. Okay, so use this. I guess I don't have to. I guess I don't have to do any kind of sort of import for the math class. But all right. So first of all, here I'm just going to use. I don't know if that's going to work. Okay, it's this formula. Let's see what happens when I copy it and paste it here. Ooh, okay. 4/3 is fine. Times pi times math pi times the radius is sphere radius times itself 3 times. Oh, we just need 3 of them. Yep. Okay. So we've got radius cubed. That's radius times radius times radius times pi times 4/3. And this is actually called sphere volume. The volume of a sphere is the radius times 4/3. 4/3 times pi times the radius cubed. So then this should print it out. Is this right? Oh, guess what I forgot? Forgot the semicolon. That's what it looks like when you forget the semicolon. It's going, excuse me, I'm expecting something here and it's not there. I'm not going to tell you what it is. You're on your own. Oh, what did I spell wrong? Is it a capital I? Maybe it is. Yeah, I guess maybe it is. Ooh. Oh, well, there it is. Okay, what's next? 1 year equals 365 days. The following program converts the quantity in days to years and then outputs the quantity in years. The code contains errors. I don't know. All right. Well, I'm gonna just, take a can. What do I say? Press start. I'm gonna see if it's this. double and double. I'm going to see if this works. No, it didn't. Next. Oh, no. It's an integer, so this has got to be int. And now this is going to be a double. Okay, so how about that? Let's see if this does it. Have I learned about converting numbers or anything? Sting, any kind of fancy kind? No, I guess not. Okay, so I think as long as there's one double precision, then the result will be double. Because then, okay, let's see if this works. I should have read what it said. All right, double, but variables are declared as integers. Integer division. So how do I do how do I do not integer division? Can I do this? That. I'm just guessing. Okay, let's see. Oh, well, I'm going to try this. I couldn't find the answer, so I'm just going to try this. This works. Oh, all right. Just got to make everything double. Otherwise, it's an error. Okay. Oh, press one. Okay, next level. What's next? Let's see. Area of a circle is pi r squared. Declare double variables. Then we're in the radius. Then put compute the area. Okay. So I got an input. Let me declare radius. So P capital I times radius times radius, semicolon. All right, what's next? All right, for this challenge activity, we're going to complete the code down here. And first, we're just going to output this 1 millimeter equals 1,000 micrometers. And the next line, we're going to read, we're going to output the value of what was read in, length, micrometers to 2 decimal digits, followed by the words a space micrometers equals space, and then the computed value here, length in millimeters to 4 digits. Micrometer. We're going to read in micrometers and output millimeters. Okay. Anyway, so we're gonna first we're gonna compute. Oh, we've already computed it, so I guess this is just a print. Okay, so first of all, we're gonna do system print out print line, I guess. This. And then we're going to print system out print formatted print, and we're going to do something, whatever the thing is, to 2 decimal digits. The length of micrometers in 2 decimal digits is 2 F. I think it's this. I'm going to put that in there. Okay, this should be just one space, I believe. Equals, and then I do this %.4 floating point. Close. So let's do this new line. Oh no, I have to put the micrometers. No, millimeters. Close the parentheses. No, I'm going to put a \n. Then close the parentheses. Oh, end with a new line. Yes, end with a new line. And then I got to put what the 2 variables were. The first one is the micrometers, which is length micrometers. Comma, the length millimeters. Paste. All right. Let's see if this is right. Yeah, I'm pretty lucky. Okay, so what's the last one? Next level. Potential energy is given by mass times the mass times the planet's gravity. This is potential energy times the height of the object. Write a program that reads double variables, object mass, planet gravity, and okay, first I'm going to declare double object mass, and then I'm going to declare double object planet gravity. These are pretty scientific problems here. And then I'm going to declare double object height. And then I'm going to read in I read all 3 of them in, it looks like. Okay. Object mass equals next double. And so it does planet gravity, and object height. Then it computes potential energy. So there's going to be a double potential energy. And that's going to be equal to, this, all three of them multiplied together. Planet gravity, object mass, object mass, it doesn't matter because it's commutative. Object mass times planet gravity times object height. Semicolon. And we're supposed to write out system out print line potential energy is percent 0.3 F new line, so \n close quote comma potential energy. Hold it, gotta make this printf. Print formatted print. So it's going to print out that. See what it does. What did I do wrong? SCNR. That's what it gotta be. SCNR. Probably got it right first time. All right. Okay. So I have taken you through 2.7 here. 2.7, and so what's left of this chapter are the remaining 2.8. All those, and I will take those up on the next video. Okay. Thanks for watching.